All right, in this video, we're going to practice finding a formula for a sequence. That's the ones we've been doing before. They gave you a formula and you could write out some terms. Well, here they're just giving you a bunch of numbers and we want to find a formula for that. Remember, the way it works is the first number, we start our n at 1. So this is a sub 1, a sub 2, and so forth. So there's got to be some kind of a pattern here, right? And this one's hopefully pretty obvious. We're just adding 4 to get from one term to the next. And when that happens, when you're adding or even subtracting the same number to get from one term to the next, we call that an arithmetic sequence. Okay, this is arithmetic. And those are very common. So to find a formula for this sequence, we want to think about, okay, every time n increases by 1, my sequence value is increasing by 4. Now that might sound kind of familiar because isn't that one way we think about like the slope of a line, right? When we talk about the slope of a line, you know, we say, hey, if we increase this by 1, then your y values are going to increase by 4. And what does that mean? That means the equation of your line would be something like 4x plus something, right? It's going to be a linear function with a slope of 4. So that's exactly what's happening here. If it's increasing by 4, then I know that my sequence must have a 4n plus something there, right? There has to be some number here. Now, usually for lines, of course, that would be the y-intercept. But one easy way to figure out that number is to just substitute in. When n is 1, we're supposed to get 6, right? When n is 1. When n is 1 here, though, I'm only getting 4. So how do I get to 6? I need to add 2 to that. And you can check it for some other values of n. When n is 2, you're going to get 4 times 2 is 8, plus 2 would give you 10, and it's going to work. Okay, so an arithmetic sequence, those are relatively simple to find formulas for. Okay, my next example, notice it's the same numbers, but the terms are alternating between positive and negative, positive and negative, positive and negative. They're still, so, okay, it's the same numbers, but it's alternating, and we've seen that before. One way to make a sequence alternate is to have a negative 1. Now, it's either going to be to the n or n plus 1. Okay, I'm going to erase one of those or scratch it out. But the rest of the sequence is going to be the exact same as the previous one. It's going to be 4n plus 2. But this is going to make it alternate, positive or negative. Now, the way we can decide which power this should be is to pick a value. A sub 1 comes out to be positive. So which power of negative 1 would make this positive 1? Negative 1 to the first or negative 1 to the 1 plus 1? Clearly, it's going to be this one, right? It's not going to be to the n. Okay, so the full sequence is negative 1 to the n plus 1 times 4n plus 2. Okay. Now, my next example is a bunch of fractions. And, you know, we could look at, you know, how do the fractions themselves change from term to term? But you may notice that there's a pattern in the numerator. Namely, we're just adding 2, and there's a different pattern in the denominator, right? 8, 11, 14, 17, that's plus 3. So we have 2 different arithmetic sequences for the numerator and denominator, and so you can just write those separately. My formula for the numerator, 5, 7, 9, since it's skipping by 2, it's going to have to start with 2n, right? Plus or minus some number. And remember how you can figure that out. If we plug in 1 for n, we're supposed to be getting 5. In this formula, 2 times 1 is only 2, so I would have to add 3 to that to generate a 5. In the denominator, since it's skipping by 3 each term, that has to be a 3n plus or minus some number. What are we getting when n is 1? We're getting 8. But when n is 1 here, we only have 3, so we have to add 5. And that will give us the formula. You can check it for some other values of n and make sure it works, but it does. Okay. Now, there are other types of sequences besides arithmetic sequences. I'll just pull this out. Okay. We've got the sequence here, 5, 10, 20, 40, 80. So clearly it's not arithmetic, right? It's not skipping by 2. But what is happening is that it is doubling, right? This is getting timesed by 2, right? Times 2. 10 times 2 is 20 times 2, okay? Whenever you have a sequence where to get to the next term, from one term to the next, you're just multiplying by the same number, this is called a geometric sequence, okay? And that's another very common type of a sequence. I found the best way to find a formula for a geometric sequence is to let's just rewrite these terms, okay? We've got 5. How do we get to the 10? We multiplied by 2, so it's 5 times 2. How do we get to 20 from there? We're just multiplying by 2 again, and that would be the same as 5 times 2 squared. To get to 40, multiply by another 2, and that's all that's happening. Whoops, this would be to the 4th power. And to make this pattern work, you could always argue that 5 is the same as 5 times 2 to the 0, right? So then I can come up with a general formula for a sub n. Remember, though, that this right here is supposed to correspond to when n is 1, right? That's a sub 1, that's a sub 2, that's a sub 3. So notice your power of 2 is always going to be 1 less than n. So your general formula here is going to be 5 times 2 to the n minus 1. Okay. One more example. So here, now, okay, anytime you see an alternating sequence, the trick is to kind of just ignore the negatives, okay? We know how to deal with that. We can always add a -1 to the n or the n plus 1. So just focus on the numbers. 4, 9, 16, 25. Okay, that's not arithmetic. You're not adding the same number to get from one to the next. It's also not geometric. You're not multiplying by the same number. So, you know, in the world of sequences, you can make up any kind of a sequence as long as there's a pattern. What you'd want to notice here, 4, 9, 16, 25, what are those numbers? Those are perfect squares, right? That's 2 squared. I'll put the negative there. 9 is 3 squared, 4 squared, 5 squared, and so forth. Okay, so we've got to put the negative there. We've got a formula for the top. How about the bottom? 8, 27, 64. You hopefully recognize those as perfect cubes, right? 8 is 2 cubed. 27 is 3 cubed. 64 is 4 cubed. And okay, you could always argue there's a 1 under there, right? Which is 1 cubed. So now let's see if we can come up with a formula for a sub n. Remember, we're starting with n equals 1. So the bottom is just going to be 1, 2, 3. That is just n cubed. Whereas my numerator, if n starts at 1, my first square is 2. So it's actually n plus 1 squared. And then to make it go negative, positive, I need to multiply this whole thing by -1 to some power. I didn't leave a whole lot of room, so let me put that -1 over here at on the end. Now in this case, I want my first term to be negative. So in this case, when n is 1, I want it to be negative. So I'm just going to have it to the n power. That'll make this -1 to the first. And then when n is 2, that would be -1 squared, which would make that positive, and so forth. And so I've got a nice formula.